Hi guys, in this video I'll be describing the solutions to science paper 2 for GCE candidates for the year 2023. So science paper 2 is actually chemistry, while science paper 1 is physics. So let's go through the paper and look at the solutions for this one. Section A, 20 marks. A1, which of the following is not a branch of chemistry? The correct answer here is D, thermodynamics. A2, which of the following statement distinguishes between an atom and an ion? An atom dash. The correct answer here is D. An atom is electrically neutral, while an ion has an overall electric charge. A3, which of the following pieces of apparatus can be used to measure accurately a fixed volume of a liquid? The correct answer here is C, a pipette. A4, identify a separation technique which can be used to separate a mixture of water and butane. The correct answer here is fractional distillation. So water and butanol can dissolve. So here we refer to this as miscible liquids. So miscible liquids can be separated by using fractional distillation due to their difference in boiling point. A5, a compound is a. The answer here is a chemical combination of two or more elements. A6, which pair of elements form a compound by sharing electrons? The correct answer here is B, nitrogen and the oxygen, which are both the nonmetals. A7, an element forms an ion, which is positively charged, 3 positive charges. What is the number of electrons, neutrons, and protons in this ion? The correct answer here is C. The electrons are going to be 24, neutrons will be 33, and protons will be 27. So the atomic number will indicate the number of protons, so mean that the protons are 27. So now to find the electrons, since we have a charge of 3, it means that we have lost 3 electrons. So to find the electrons, we simply subtract 27 minus 3, which will give us 24. That's why the electrons are 24, because we've lost 3 electrons. Then to find the number of neutrons, we simply subtract the mass number from the atomic number. The mass number here is 60. So neutrons will be 60 minus 27, which gives us 33. So that's why the correct answer here is C. A8, which of the following is not a characteristic of an acid? An acid dash. The correct answer here is B, produces hydroxide ions when dissolved in water. This is a characteristic of an alkali. A19, which statement explains why salts do not conduct electricity in a solid state of matter? The correct answer here is A. The delocalized electrons in salts are not free and not mobile in solid state, and that's why they do not conduct electricity. A10, when strongly heated, calcium carbonate decomposes according to the chemical equation shown. Given that 500 grams of calcium carbonate were thermally decomposed, calculate the volume of carbon dioxide gas which was produced at room temperature and pressure. The correct answer here is A, 120 cubic decimeters. So to calculate this one, we first need to find the number of moles of carbon dioxide which are produced. Now, from the equation, which is already balanced, we can tell that 1 mole of calcium carbonate decomposes to form 1 mole of calcium oxide and 1 mole of carbon dioxide. So, mean that if we know the moles of calcium carbonate, we'll be able to also find the moles of carbon dioxide. So, first thing we need to do is find the relative molecular mass of calcium carbonate. So, the mass of calcium is 40 plus mass of carbon, which is 12, plus the mass of the 3 oxygen atoms, which will give us 16 by 3. So once we sum that up, it will give us a mass number of 100. Now that we have our 100, we can now calculate our number of moles. So number of moles will be equals to 500 grams divided by 100 grams per mole. So that gives us now the number of moles of calcium carbonate to be 5 moles. So since now we have 5 moles of calcium carbonate decomposing, it means it will also produce 5 moles of calcium oxide and 5 moles of carbon dioxide. Now that we have our moles, we can now use the molar volume formula, which will be the volume of a gas will be equals to the number of moles times the molar volume. At RTP, the molar volume is 24 cubic decimeter per mole. So now we can substitute into our equation. So our number of moles is 5 moles by 24 cubic decimeter per mole, and this will give us 120 cubic decimeter. So that is how we find our answer. A11. Why should water never be added to an acid when diluting a concentrated acid? The correct answer here is B. The process of diluting acids is exothermic, and the concentrated acids have a high affinity for water. So that's why we never add the water to acid, but add the acid to water. Okay, so the easiest way to remember is know which one is safer to spill. So if you have water in a cup and you're adding the acid, the water, once the water spills out, it's fine. But if you have acid in a beaker and you pour in water, now when the acid spills up, it will actually burn. So that's why we always add the water, acid to water, never water to acid. So don't forget that rule. A12, the following graph summarizes the reaction between the powdered calcium carbonate and the dilute hydrochloric acid of different concentrations and show the volume of gas produced. Which graph shows the slowest chemical reaction? So which reaction here was the slowest? The correct answer here is D, reaction number 4. So we can tell that here reaction number 4 takes long for the gas to reach its maximum. So for 1, it's actually much faster, but 4 is actually the slowest. It took the most time. Okay. A13, element X has valency electrons equal to 6. In which group of the periodic table does the electron X belong? The correct answer here is A. It belongs to group 6. So the valence electrons are electrons which are found in the outermost shell. So if it has got 6 electrons in the outermost shell, it will actually belong to group 6. So the correct answer is A. A14. How are elements on the periodic table arranged? They are arranged according to their proton numbers. So the correct answer is D. So they are arranged according to increase in their proton numbers. A15. Which of the following explains why nonmetals are poor conductors of heat and electricity? The correct answer here is A. The electrons in them are localized and not mobile. So hence they cannot conduct what? Electricity. A16. Which of the following is not a property of a typical metal? The correct answer here is A. Brittleness. So breaking easily is not a property of a typical metal. A17. Hydrogen can be manufactured from methane according to the following reaction scheme. What are the identities of substances M, N, and P? So here the reaction is steam reforming. So the correct answer here is C. M is steam. The catalyst used is nickel, and the products formed is hydrogen as well as oxides of carbon. So the correct answer is C. A18. Which of the following is true about chlorine, bromine, and iodine? They Correct answer here is A, are colored. So bromine will be reddish, gas or reddish liquid. Chlorine is a green gas. Iodine is slightly silver. So all these compounds are basically colored. 19. Which of the following are products formed in a chemical reaction between an alcohol and a carboxylic acid? The correct answer here is A, an ester and water only. A20, the following structure shows a common polymer which has 3 monomer units. Name the monomer of this polymer. The correct answer here is C, glucose. Section B, 45 marks. Answer all questions in this section. Write your answers in the space provided in this question paper. B1, part A1, define the term matter. Matter can be defined as any substance that occupies space and it has a mass. A2, give the basic unit of matter contained in carbon dioxide. The basic unit of matter in carbon dioxide is molecules. Part B, state 2 challenges that can be brought about by activities done in chemical industries. So one of the challenges is some byproducts are harmful to the environment, like CFCs, which will damage the ozone layer. Secondly, plastics which are produced can actually cause land pollution. Part C, explain why it is not advisable for learners to enter the laboratory in the absence of a teacher. This is simply to avoid the accidents. So this was question number 1 for section B. B2, using the knowledge of kinetic theory of matter to answer the questions that follow. Part A, explain why an inflated balloon which is placed in a refrigerator slowly starts to shrink and reduce in volume. When a balloon is placed in the refrigerator, the particles will actually lose kinetic energy and they'll start moving close to each other. Hence, the volume will reduce. Part B, with reference to energy changes, what type of process takes place in A above? So once we have the balloon in the fridge, what will basically happen is that this will be an exothermic process because heat is what lost. Part C, explain why wet clothes dry faster on a warmer day than a colder day. So on a hot day, we are actually going to find that the water molecules will actually have more kinetic energy, which will cause them to move further apart, forming a gas. So they evaporate from the clothes, hence making them dry faster. B3, the experimental setup that follows shows a mixture of sand and iodine crystals in an evaporating dish. Part A, describe how the mixture of sand and iodine crystals can appropriately be separated. So to separate the mixture of iodine and the sand, we are going to use this sublimation. So heating the mixture will cause the iodine crystals to sublime and the sand will be left behind in the evaporating dish. Part B, explain why bottled water is not pure water. So bottled water, normally it will actually be a mixture containing dissolved minerals and the air. So that's why it's not pure because it already contains minerals. That's why we call it mineral water. Part C, give one criterion for purity of a substance. So we have quite a number of criteria of purity, but here we're only going to write one, and the one we're going to use is boiling point. So you can use boiling point, freezing point, and density as well can be used to tell the purity of a substance. B4, part A, Figure 1.1 shows an electronic structure of element Q. Name element Q. So element Q from the electronic configuration is 287, which is having total number of electrons will actually be 17. And on the periodic table, the atom with 17 electrons is chlorine. So our element here is chlorine. Part 2, state the period of the periodic table where element Q belongs and explain your answer. So chlorine, from the configuration, we can tell that it has got 3 shells, so it's going to belong to period 3. So it will belong to period 3 because it has got 3 shells. Part 3, explain how an atom of element Q acquires electronic stability. So it will acquire electronic stability by gaining or sharing one electron. Part B, explain what you understand by the term nucleon number. So the nucleon number is the sum of protons and neutrons in the nucleus of an atom. So that is also what we refer to as the mass number. B5, part A, distinguish between an acid and a base. So the difference between an acid and a base is that an acid is a proton donor, while a base is a proton acceptor. Part B, explain what you understand by the term salt. So a salt is simply a substance which is produced when the hydrogen ion of an acid is replaced by a metal ion or ammonium ion. B6, part A, define the term mole. Mole can be defined as the amount of substance which contains the same number of particles as the number of carbon-12 atoms in 12 grams of carbon. Part B, the concentration of sodium hydroxide is 0.25 moles per cubic decimeters. Calculate the number of moles of 0.25 mole per cubic deciliter of sodium hydroxide solution contained in 250 cubic centimeters of this solution. So before we start our calculation, the first thing we need to do is to convert the volume we've been given into cubic decimeters. So here, our volume, we need to divide it by 1000. So that will give us 0.25 cubic decimeters. Now, using our formula for concentration, concentration is equals to number of moles divided by the volume. So here we are calculating the number of moles, so we make moles the subject of the formula. So meaning that the number of moles will be equals to concentration multiplied by volume. So our concentration, we are given to say it's 0.25 moles per cubic decimeter multiplied by the volume, which is 0.25 cubic decimeter. So once we multiply, we are going to get 0.0625 moles. So that is the number of moles of sodium hydroxide which will be contained in 250 cubic centimeters of the solution. So that is how we find the answer. Part C, iron metal is extracted from an iron ore called hematite in a blast furnace during a reduction reaction using carbon monoxide gas as a reducing agent as shown in the following equation below. Calculate the mass of carbon monoxide gas required to reduce 3,200 kilograms of iron 3 oxide in the blast furnace. So to calculate our moles, we have to make sure we look at our equation. So from our equation, we are told to say 1 mole of iron ore will actually produce 3 moles of carbon monoxide. So we then convert our elements into masses. So here we will multiply, we have 2 atoms of iron Then we add it to the 3 atoms of oxygen, and we also have our 3 moles of carbon monoxide. So meaning that here we now reduce with the mass numbers. So iron, the mass number is 56, oxygen is 16, then carbon is 12, and the oxygen 16. So once we multiply and add the iron, the iron ore, our mass is 160, and we're able to form 84. So now from our equation or our sample size, we are given to say we have 3,200 kilograms. We end up producing what? X. So to find X, we cross multiply. So that will give us X will be multiplied by 160, and the 3,200 grams will be multiplied by 84. So to find X, we divide by 160 on both sides. So now X will be equals to 3,200 kilograms times 84 divided by 160. So this now gives us 1,680 kilograms. So then that is the mass of carbon what? Monoxide. B7, part A. Describe how the action of heat on the carbonate of a metal depends on the position of the metal in the reactivity series. So the position of the reactivity series, so the metal that will actually occupy a higher position will actually form stable carbonates that do not decompose when heated, while lower metals form unstable oxides that easily decompose when heated. So that is how the position will be able to tell how the metal will be actually able to decompose or not decompose. Part B. Transitional metals and their compounds can be used as a catalyst. Part 1. Explain what is meant by the term catalyst. A catalyst is actually a substance that will alter the rate of a chemical reaction without itself being chemically changed. Part 2. Explain why metals are good conductors of electricity and heat. They normally have delocalized electrons which are free to move and they carry heat or electric energy. P8. Greenhouse gases are given greenhouse factor values. The greenhouse effect of a gas increases with the factor value. The following table 8.1 gives the information of 4 different gases: carbon dioxide, methane, the nitrogen oxide, and the carbon trichlorofluoride. Part A. Identify the gas which has the greatest effect on the environment. Give a reason for your answer. The gas here with the greatest effect on the environment is the carbon trichlorofluoride because it has the highest greenhouse factor of 21 per thousand. Why is an increase in the percentage of methane more worrying than the same percentage increase of carbon dioxide? The reason is simply because methane has a higher greenhouse factor of 30, while carbon dioxide has a lower greenhouse factor of 1. So when you increase methane, means that you are increasing its factor as well. So that's why methane will be more worrisome. Part C. What other environmental problem besides its action as a greenhouse gas is caused by carbon trichlorofluoride? The other problem is that it will actually deplete the ozone layer, which protects against skin cancer and cataracts. B9. Alkanes form a homologous series of organic compounds which are called paraffins. Part A1. State the general formula to which alkanes belong. So the general formula is as follows. We have Cn H2n plus 2. Part A2, draw the display structure formula of pentane. So pentane will have 5 carbons and it will have hydrocarbons. Part B, give 2 reasons why cracking of large hydrocarbons is important. The first importance is that it produces small useful hydrocarbons, and secondly is that it prolongs the lifespan of natural crude oil reserves. Part C, justify why alkanes are sometimes called the paraffins. So these are normally referred to as paraffins because they are chemically unreactive. So that's why we call them paraffins. Section C, 20 marks. Answer any 2 questions from this section in a separate answer booklet provided. C1, the scale in a kettle contains calcium carbonate and the amino sulfonic acid is used to remove this scale. This acid reacts with the scale and produces a gas. Part A, the apparatus in figure C1.1 was used to collect the gas formed when excess acid was added to small amount of the scale. Part 1, how could you tell that a gas is being produced? So we can tell that a gas is being produced from this experiment due to the bubbles which are produced. Part 2, name the gas produced. So the gas which is produced is carbon dioxide gas, because here we are reacting a carbonate with an acid. So carbonates with acid react to form carbon dioxide gas, salt and water. Part 3, describe a chemical test for the gas produced. So carbon dioxide gas will normally, once bubbled through lime water, it will turn lime water milky. So that is the chemical test for carbon dioxide. Part B, Elena measured the total volume of gas produced over 120 seconds. His results are shown in table C.11. Part 1, plot a graph of the results against time, volume against time on the graph paper provided. Circle the point which seems to be incorrect, and 3, calculate the average rate of this reaction. So we'll start with the part 1, which is to plot the graph of volume against time. So first thing we are going to do is write the title of the graph. So here our title will be graph of volume against time. Then we highlight our y-axis and also highlight our x-axis. Then we can now throw in our values for the x-axis. So we can have increment by 10, and we indicate the units for our x-axis, which is time in seconds. Then we also indicate our values for the y-axis. So after indicating our value for our y-axis, we also indicate the units, and this is the volume in cubic centimeters. Then we start now plotting. So for time, 0, our unit is 0. Next is our time is 5 seconds. So at 5 seconds, our volume is 20. Then next, our time is 20 seconds, and our volume will be 40. Next is our volume. Our time is now at 35, and at 35 the volume is 50. Then the next time we have is 55, and at 55 our volume is 60. Then the next, our time we have is 70. So with our time being at 70, the volume is at 75. Our time is at 90, then our volume is at 65. Then next we have our volume at 120, and our volume remains the same at 65. So that makes us plot our graphs. So once we've put our points, next we now join these with a freehand. So we join this point to that point, this point to that point, to the next point, to the other point. So that now makes our graph. So our graph is now done. So next part of the question is to circle the point which seems to be incorrect. So the point which seems to be incorrect is our 75 volume, which is at our time of 70 seconds. So that is our incorrect point. So we are done with the first two questions. So the next one now is to calculate the average rate of this reaction. Okay. So to calculate the average rate of the reaction, we know that the rate of the reaction will be equals to total volume divided by time taken. So what time did it take for this reaction to end? The reaction actually ended at 90 seconds. So meaning that here, and the total volume was 65. So the volume we have is 65 cubic centimeters and our total volume is 90 seconds. So here don't go for 120. Otherwise the reaction is already done. Okay, so once we divide, we are going to get 0.72 cubic centimeters per second. C2, zinc blende is one of the ores for zinc metal. Part A, state the chemical name for zinc blende. So the chemical name for zinc blende is simply zinc sulfide. Part B, describe how zinc metal is extracted from zinc blende, including the necessary balanced chemical reaction. So to extract our zinc, we first need to concentrate our ore by what is known as flotation. So then the concentrated ore is roasted to form zinc oxide. So this will involve us reacting zinc sulfate. We react with oxygen to form zinc oxide as well as sulfur dioxide. So the zinc oxide is then reacted with coke to form zinc and carbon monoxide. The carbon monoxide will either react with the zinc oxide to form zinc, and that is how the zinc is actually produced. Now, once this zinc is produced, it's actually produced as a gas, so it has to go through a condenser, which will then condense it into a molten liquid, and that is how the zinc will be collected. So this is how the extraction of zinc is done. Part C, state two uses of zinc metal. So zinc will actually be used for galvanization, and it can also be used for making the alloy brass. Part D suggests one environmental problem that is a consequence of the extraction of metals. So with the extraction of metals, we have gases which are produced, like for example, sulfur dioxide produced will actually cause acid rain. So that is the environmental problem. C3, ethane and ethene are both the organic compounds. Part A, compare how they react, if at all, with 1. Oxygen gas. So with oxygen gas, they will both react. So both ethane and the ethene will react with oxygen to produce carbon dioxide and water, which is known as a combustion reaction. Secondly, hydrogen gas. So with hydrogen gas, what basically happens is that ethane does not react with hydrogen gas, while ethane reacts with hydrogen gas to form ethane. This is what is known as hydrogenation. So this process is what is actually used to form margarine, where we actually turn oil into margarine. Okay. Part 3, write a chemical reaction for any of the reactions in 1 or 2 above. So we are going to write the first reaction, which is combustion. So we are saying ethene will react with carbon dioxide, with oxygen to form carbon dioxide and water. Then secondly, we are saying ethene will react with the hydrogen gas to form ethane. So that is what is known as a hydrogenation reaction. So any of the two. Okay. So part B, draw the display formula for ethane. So the first display formula we are going to write is ethane and ethene. So we are saying ethane, our display formula. So this one will have a single bond, two carbons, but single bonds. So this one will be our structural formula. Then coming to ethene, so this one will still have two carbons, but it will have double bonds between the carbons. So this will be the general formula for ethene. Part E, describe a chemical test that can be carried out to distinguish ethane from ethene. So the two can actually be distinguished by testing for the carbon bond. So the gases will need to be passed through bromine solution. So ethene will actually decolorize bromine water, while ethane does not decolorize because it has double bond. So that is the chemical test. So this brings us to the end of our revision paper. If you enjoyed the video, make sure to comment, like, and subscribe. I'll see you guys in the next video. Bye for now.